Hey there, everybody. We're going to be getting started here in just a second. So I'm going to put up the timer and then, hey Tate, how's it going? I'm going to put a timer on the screen and then I've got to go do daddy stuff just for a minute. If you haven't checked the your assignments, I did post the ones you might have missed. 7 minutes. There we go. All right, so here's our timer. It would help if I unmuted myself when I start talking. If you have not checked your assignments that you turned in for correction notices, you might want to do so. As I was putting the grades in, well, at least marking some of the grades, that is, I was amazed that exactly 50% of classes, students turned in the work for corrections ahead of time. I'm not sure if that's good, great. I don't know. I'm just hoping I have less students this week on the list of people who did nothing. So there's really two kinds of problems we can work on. I'll leave it to chat and decide what we do because you guys are actually here. We can do equations with variables on both sides. That includes equations with parentheses. Or we could focus on determining the number of possible solutions, or determining how many solutions there are. Those are the ones that are like exactly one answer, or no answers, or infinite answers. So those are essentially the skills we're going to get to. As soon as I'm not yawning. All right, bye-bye, timer. Okay, chat. So what would you prefer? Are we going to work on equations and balancing and getting answers, or do you guys want to work on determining how many answers there are in a system? I'm asking which ones you guys would prefer. I'll put in chat too. I wonder if I only notice how much I'm yawning because I'm on camera. I wonder if I yawn as much at school on a normal day. Who knows? Okay, chat, if you don't make a decision, I guess I'll kind of just pick. But I figured since you're here, I'd leave it up to you what we tried out first. Okay. That sounds like a plan. So, for those of you watching on YouTube, on the replay, what we are going to start with is equations with variables on both sides. That's the goal anyways. So let me go grab us some problems. I think I'm going to go ahead and start with a variable on both sides where they have parentheses. I've had a few people on their assignments just write the words "I don't know" on those assessments. Okay, let's see. Yeah, here's a good one. Getting my math practice standards out. Okay, well, let's start. Let's make sense of the problem and persevere in solving it. Okay, well, it just says solve for E. Okay, so I'm gonna be doing some inverse operations to get E all by itself. Okay, and so we're gonna start off by just writing this down on our piece of paper. So 7 parentheses to E minus 1 parentheses minus 3 equals 6 plus 6E. Make sure I wrote down right. 7 parentheses 2e minus 1 and parentheses minus 3 equals 6 plus 6e. Okay. So the first thing I'm noticing that I'm going to want to do is combine. No, I can't combine like terms yet. I've got this distributed property right here where I've got to multiply the 7 times both terms on the inside. So 7 times 2e is going to be equal to 14e. And then 7 times a negative 1 would be negative 7. And I still have subtracting 3. I still have an equal sign. I still have a 6. I still have a positive 6e. Okay. So now the next thing I'm going to notice is the like terms. I've got a 14e. Oh, let me back that up. The things that I have that are like are the negative 7 and the negative 3. They're both on the same side of the equation, and they can be put together. So, hey, Austin, good morning. So this would be so I still have 14e. Now minus 7 minus 3. If I'm at negative 7 and I subtract 3, I'm going to be at negative 10. And I still have this positive 6 and positive 6e over here. Okay, so now I'm going to have to do some inverse math where my whole goal is to get e by itself. So we end up at e equals something. So we've got some abstract laws that we use a lot. And those abstractions are that anything, I'll put them over here, anything being combined with its opposite is going to equal to 0. I mean, that also, if you were to say it a different way, anything minus itself equals 0. So that's an abstract rule we're going to be abusing a lot. And the other one is that anything divided by itself is equal to 1 whole. So those are the abstract rules we're going to abuse a lot. We have already started making good use of structure. And I think that inverse operations is the tool that we're using to solve these problems. So let's just be very precise with our work and continue. Okay. So. If I were to take away 6e from both sides, because of our abstract rule that we were just talking about, these would make a 0, which is what I want. I want to get them over to the left side. And then if I were to add 10 to both sides, that means that these would cancel out, leaving me with an equal sign. 14e minus 6e would be 8e. And then 6 plus 10 would be 16. So then if I divide both sides by 8, according to our abstract law, 8 divided by 8 is equal to 1 whole. So it'd just be 1e. 16 divided by 8 is 2. So in this case, e would be equal to 2. So, okay, I'm reading chat. Which assignment? I'm going to be pulling up a new problem while chat figures out what question they're asking about. Okay, assignment 5, which number? I have written down here. I'm looking at my own scrap work for M5. First assignment 5, which number? Okay. No, I remember yours, and those numbers, if those had been the right answers, I probably would have given you credit, and they were not. Yeah, no, I try to give people a little bit of leeway when it comes to their responses and what they type out. So if it even looks correct, I would have given credit. Let's snag us another one. I wonder if I can find one with decimals. I'm gonna need to change exercises for that. Okay. Okay. Let's try this one. All right, how about this one? All right, so I'm supposed to solve for n, but still the first thing I'm always going to do is just write down the question or write down the equation. So negative 4n minus 8 equals 4 parentheses negative 3n plus 2. Negative 4n minus 8 equals 4 parentheses negative 3n plus 2. Okay. So I have this set of this distribution I've got to do. I've got to multiply the 4 times both terms on the inside. So I'm still going to have negative 4n. I'm still going to have minus 8. But 4 times negative 3n would be negative 12n. And 4 times 2 would be 8. Okay. Now I can combine like terms. No, I can't combine any like terms because they're on the wrong side of the equation. What I've got to start doing now is my inverse operations. So if I were to, now this is where you get a little voice and choice of where you go with this. I try to do what I can to make sure that my variables are positive. So if I were to add 4n to both sides to cancel out over here, I'd still end up with negative 8n and blah. So I think I would rather add 12n to both sides. So I'll end up with a positive number of n's. So when I add 12n, these are going to cancel. Now that means I'm going to go ahead and add 8 to both sides so that I don't have my constants, those numbers without variables, on the same side as my variable expression. So the negative 8 and the positive 8 cancel each other out. So what are we left with? So negative 4n plus 12n would be 8n. and then I have an equal sign, and then I have 8 plus 8, which is 16. So now I would divide both sides by 8. And we get 1n equals 2. Because as we all know, 8 divided by 8 would be 1. And 1n is just the same as just saying n. So that would be equal to 2. So what did we do there? Well, we reasoned abstractly when we were canceling stuff out. We persevered in finishing the problem, obviously. I constructed a viable argument. I guess I should go back and plug in 2 to get credit for that. If I were to go back and put in a 2 here and a 2 here, negative 4 times 2 would be negative 8. Negative 8 minus 8 would be negative 16. That'd be this side. Negative 4 times 2 would be negative 8. Negative 8 minus 8. Yep, that'd be negative 16. And if I put a 2 there, that'd be negative 3 times 2 would be negative 6. Negative 6 plus 2 would be negative 4. And then negative 4 times 4 would be negative 16. Yep. So I just made my argument to prove that, yep, I'm right. The tools and structure we used were to keep our equation nice and organized and use our inverse operations. We were very precise with our work, but a big one, I think, for this is that I'm using repeated reasoning because I've done several of these problems now, and I'm just kind of remembering the motion of how it goes. That just makes them all easier. I think we should do one with decimals. Give me a second to pull it up. Those don't have decimals. 1 second. Yeah, these seem to be giving people headaches. I don't think they should, but that's just me saying words. All right, paper and pencil out. Let's try this one. The strategies are not changing. The only thing that is different about this one that is just has decimals in it. That's the only difference. It shouldn't affect people that much, and somehow it does. So 9 plus 3.5 g equals 11 minus 0.5 g. So this one's already set up kind of post parentheses. You don't have to worry about that. All you have to do is the inverse operations and then solve for the letter. So in this case, if again, I'm the one that wants to have positive variables if I can. If I were to subtract 3.5 g from both sides, I mean I could do that, but I would have a negative value. So instead, what I think I'm going to do is I'm going to choose to add 0.5 g to both sides. Because I know that'll come out to be a positive value. That means that these two cancel each other out because of our abstract rule. Now, if I'm going to have my g's on the left side, it means I better get rid of this 9. So let me do the opposite. I'll take away 9. I have to do that from both sides. So those go away. Well, we end up with 3.5g plus 0.5g. That's 3.5 plus half. We 4g. 11 minus 9 is equal to 2. So the last step would be to divide both sides by 4. And by my calculations, because 4 divided by 4 is equal to 1, you'd end up with 1g equal to 1/2. I guess I know someone's going to say that's equal to 0.5, which is true. 2 divided by 4 can be simplified into 1/2. So yeah, I would expect either the answer of 1/2 or 0.5. Yeah, so I don't know why people get weirded out when they're doing the exact same steps, except there just happens to be a variable in it. I mean, not variable, decimals in it. Okay, so chat, do you want to do more variables on both sides, variables with parentheses, or do we want to move on to how many solutions there are in a system? That's the ones where it's like there's one answer or no answers or infinite answers. Variable on both sides? Okay. No, I'm good. I wonder if it's the cap that makes me look down. I've been drinking my waters. Got a good night's sleep. I don't know why I'm yawning. No, I'm good. All right, here's another one. Let me grab it with a clip. Are continuing on our quest with variables on both sides. Take a look at this one. So it's 4x plus 8 equals 7.2 plus 5x. 4x plus 8 equals 7.2 plus 5x. Yep. Okay. So we don't have any distributive property stuff to do. We don't have any like terms we can combine. We're launching straight into inverse operations to figure out what x is equal to. So because I love having positive variables, if I were to take away 4x from both sides, I'd end up with a positive x on the right side. I guess I'm going to do this one counter to what I normally do. Let's just say there's a student that just always wants x on the left. Okay. So if I were to take away 5x from both sides, just to make sure my variables are always on the left side, dealing with negative variables isn't the end of the world. So these will cancel each other out. And that means that we'd want to take away a from both sides so that the constants end up on the right side. So what do we end up with? We would end up with 4x minus 5x to be negative 1x. These go bye-bye. You're rich. Okay. 7.2 minus 8. I'm just thinking that's 7.2 minus 8.0. Now, 7.2 is smaller, so it's going to be a negative answer. And the difference between them is 0.8. So, yeah, I think that the negative answer would be negative 0.8. Okay, now the last step, because we don't want to know what negative 1x is equal to. We want to know what x is equal to. So we've got to divide both of these by negative 1. And this is sort of the price we paid for not subtracting 4x from both sides, because this gave us a negative variable. So once we divide by negative 1, which isn't all that difficult, or anything. What we end up with is x equals, now negative divided by a negative is going to be a positive answer, and anything divided by 1 is itself. So this just means 0.8. Well, as much as these are really important, especially for higher level mathematics, I think that for the sake of people that are going to watch this on the replay, I have to do some with the number of possible solutions. So, a quick explanation about what's going on here. This is sort of one of those moments that I wish I had my board. I miss having being able to have my board. Anyway, so let's pick a good color. Okay. So if you imagine a coordinate system with a y-axis and an x-axis, and then you've got some lines going through the system. There's a line, and there's a line. Okay. There's going to be a spot usually like this. There's usually an xy value where the two lines cross. Now, in your problems, it's going to say this is the solution. This is what they wanted you to find out. So if you ever, when we get to our questions and they're asking for the solution, this is what they're referring to. Do the lines cross once? This would be the visual image of when they have exactly one solution. It's the place where the two lines cross. That's the x value and the y value where the two lines happen to be in the exact same place. But that's not how it works all the time. Sometimes you'll have lines that do something a little different. Like these two. So if this was the visual representation of one of your problems, in this case, there is no solution. So what we say here is that they have no solution because they never cross at an xy coordinate. They are parallel. If they are parallel lines, they have the exact same slope and they will never ever cross. They'll never touch. So this is the one where there's no solution. But then there's the third option. What if our lines look something like this? That's pretty good. In this case, the two lines are the exact same. And that means they've got an infinite number of XY solutions that are the exact same. Like they cross infinite number of times because every single X value and every single Y value, they match up. So those are the visual images of what we're trying to prove here. So what they end up doing is asking you in an algebraic way. They don't ask you in a visual way. It would be possibly too simple, but let's go ahead and grab a problem. And I'll make the connection for you. Okay, this one of the students that got a 50% did not get it correct. Okay, so it's our job right now to try and figure out whether it has no solutions. And again, just to connect this back to what we were talking about. So no solutions means parallel lines, they never crossed. That's what no solutions means. Then you've got exactly one solution. That's what it means to have exactly one solution. They cross once, exactly once. And then infinite solutions means they're going to cross always at all X and Y values. Now, the way this will show up for us, so the way this represents itself, so if they never cross, we're going to get something really strange like, that's not what I wanted. We'll get something really strange like 9 equals 12, which doesn't make any sense. If they cross once, we'll end up with something like X equals 4. We'll just end up with some sort of an actual answer. If we get one answer, even if it's a fraction or a decimal or a negative, if we come up with one answer, we know there's one solution. And then for C, infinite means we'll get something that's always true, like 17 equals 17. We'll get something that's just always true. So once we start working on the equation, those are the three kinds of things we're looking for. If we get something where it's like two numbers that shouldn't equal each other, that's going to be a no solution system. If we get an X equals value, we're good. That's an exactly one answer solution. And if we get something like 17 equals 17 or two sides of an equation that are identical, we have found an infinite solution system. So another thing that these problems kind of took away from you is the ability to see that this problem they gave you really started out as y equals 3 parentheses y plus 41 and y equals 3y plus 123. That's where this came from. It was a system of equations, and they just put them equal to each other because they are both equal to y. So 3 parentheses y plus 41 in parentheses and 3y plus 123, they're equal to the same thing. So these are two lines, and we're just trying to see what kind of solution they might have. So what we're going to do is write this down on our own paper. So let's start with 3 parentheses. Let me change that color. 1 second. 3 parentheses y plus 41 end parentheses equals 3y plus 123. And now we're going to go ahead and start using a lot of the same skills we've been using this morning for the past almost 40 minutes. So we're going to do the distributive property where I have to multiply 3 times both terms. So 3 times y is 3y. 3 times 41 would be, well, 3 times 40 is 120, and 3 times 1 is 3, so that would be plus 123 is equal to 3y plus 123. And I'm pretty sure you guys have clever eyes. Can you tell which one it's going to be? You might notice I've got 3y plus 123 on the left side. I've got 3y plus 123 on the right side. They're identical twins. So the answer to this one is C. They are going to be infinite. So as soon as I started working with the equation, I realized that both sides are the exact same. They're the exact same line. They cross always. So there are an infinite number of answers. Okay, so now that I've given that a great explanation, for everyone in chat, I want you to write this next one down in your own paper, and let's see how you do. And if you're watching this on the replay on YouTube, once you see the problem, pause it, try to work it out, see if you can come up with your opinion, and then unpause it and see if you got it right. Okay. So that'd be 12z minus 6 plus 15z equals 27z minus 5. 12z minus 6 plus 15z equals 27z minus 5. All right. So for those of you that are live here in chat, I'm going to give you a minute to get a head start. And if you're watching at home, pause it, try to work it out, and then see if you agree with the rest of us. Okay, so the first thing I want to do here is combine like terms, because I've got a 12z and a 15z, and they would add together to make 27z. Minus 6 equals 27z minus 5. Now, because of my experience and my repeated reasoning skills, I know where this is going. But in case you don't, what you would do next is you could subtract 27z from both sides. And because we know our abstract rules, they make zeros. So what you end up with is negative 6 equals -5. The problem with that is that that does not make any sense. If you're on YouTube and you scroll back, you'll realize that when you get two numbers that should not be equal to each other like this, that is your signal that this is a no solution system. These lines are parallel, they will never cross. They have the exact same slope. Okay? All right, so let's try another one. And I might just say this is the last one for the day unless someone has something very specific they want to ask. Okay. So let's see. First thing I'm going to want to do is just go ahead and write this down for myself. So 5x plus 8 minus 7x equals negative 4x plus 1. Double triple check. 5x plus 8 minus 7x equals negative 4x plus 1. Okay, sure. So I've got a 5x and a negative 7x. They can combine to make negative 2x. I still have the plus 8 equals negative 4x plus 1. Okay, so if I were to add 4x to both sides, that means these go away. And if I were to subtract 8 from both sides, these go away. So what are we left with? Negative 2x plus 4x would be positive 2x. And then 1 plus negative 8 would be negative 7. So I can divide both sides by 2. And it turns out that x is equal to negative 7 halves. Now, I'm not going to be that concerned over the fact that it comes out to be a fraction or that it comes out to be negative or both. The fact is that x came out to be a thing. X came out to be a value. So apparently when x is equal to negative 7 halves, the two lines cross. So this isn't exactly one solution system because it came out to variable equals something. That was nice. We had an infinite, a non, and then exactly one. Okay. Well, unless anybody in chat has a very specific question about like, hey, one like number so and so and problem such and such, we're going to call it a day. So I'll give you a minute to guys to look at your assignments real quick and see if there was something that really interested you. Okay, well, I guess that is going to do it for today. I'm glad you guys showed up. I hope everyone is staying healthy and having a good time at home. I know it's getting weird, but it's also becoming sort of normal. If you have any more questions, please screenshot them, send them to me via email, and we will proceed whenever we see each other next time. All right, take care, guys.
Hello.